Voltage, current, resistance. In this video, we're looking at basic electrical units of measurement, how they apply to e-bike systems, and how to measure voltage, current, and resistance. Why it matters? Because it's needed for electrical problem solving, and it'll be able to help you answer customer FAQs, and also key concepts used a lot in later videos. Prerequisite VODs, nothing. Electricity is like traffic. Think of it as the cars as groups of electrons or electricity flowing down a highway. The highway is like the wire the electricity flows through. So let's begin with volts. It's the electrical potential difference, like how eager the drivers want to move on average. In e-bikes on two identical motors, a higher voltage means a higher top speed within the system's limits. Our example here, we have 3 volts. Just think of that as like on average 3 k's an hour. Everyone's pretty cruisy, moving slow. Whereas this one, 65, everyone's a lot more eager to get where they need to go. Amps. Measurement of current, like the number of cars passing over a point on the highway over 1 second. In e-bikes on 2 identical motors, higher amps means more torque and acceleration within the system's limits. Our example here, we have 4 amps or 4 cars on a 1 second section of highway, and here we have 7.5 cars, so 7.5 amps. Ohms, designated by the Greek letter omega. Measurement of resistance, like obstacles or speed limit, slowing traffic. In e-bikes on 2 identical motors, the higher resistance equals more voltage sag and wasted energy as heat. So our example here, speed limit of 25, because there's obstacles, thin wire or things slowing down traffic. And here we have an example where it's smooth sailing. So how it all works together. The relationship between electricity is you have ohms or resistance, slowing down the flow of current or amps, which is being pushed or motivated by voltage. So you can always calculate what's going on here as well. This is nice to know, but it's not essential. It's called Ohm's law. So if we want to solve for voltage, highlighted in blue, it's simply amps times resistance. If we want to solve for current or amps, it's simply voltage divided by resistance. And if we want to solve for resistance, it's voltage divided by amps. So as an e-bike mechanic, you'll use a multimeter a lot, especially when dealing with diagnosing electrical faults. A multimeter looks like this thing here. Voltage is the most common thing you will measure, followed by resistance, but usually you're not trying to find a value with resistance, unlike voltage. It's more of the fact that you'll be looking for continuity to see if there's infinite or nil resistance. You'll find out more about that later when we cover things like conductors and insulators and circuits. And then there's amperage, which is almost never measured. I could only think of the case where that would be if you're looking at you're doing some testing on a specific battery that you wanted to see, like output. A lot of the time that data is actually built into instruments on the e-bike, so you don't have to worry about that. So here we have a video that goes over measuring voltage, current, and resistance. We start by turning the multimeter on. All what we have to do is measure the voltage source with positive and negative. It's 4.14 volts, and if we flip it, it's just going to show negative polarity, so negative 4.14 volts, which is fine. Once we're done, we simply turn it off. Next up, we're testing resistance. We have a 7.5 ohm resistor. We turn our multimeter to resistance, and we get the probes and put it across the resistor. After a little bit, the multimeter will read pretty close to 7.5 ohms. Note, you have to use a little bit of force sometimes on the probes to get a good electrical connection. On this multimeter, to measure amps, I need to change the positive probe to a different port. Then I set the multimeter to amps. I've removed a sleeve from the positive probe just to get a better contact. And now I am testing the system. It is about half an amp. And just like voltage, you can always measure in reverse polarity. It's just going to show a negative. Always check with the instructions on your specific multimeter when measuring current, because it can damage the multimeter if you're not careful. When you're done, make sure that you always reset your probe position back to voltage and resistance measuring. Remember, voltage and resistance is the most common thing that you will be measuring in the workshop. If you need to measure a high amount of currents, you can use a clamp attachment. Unlike the method that I've shown you so far, which is usually good for 10 amps in most multimeters, this clamp attachment attaches around a wire measuring the electromagnetic field. But at the end of the day, even in my 5 years as an e-bike mechanic, I've never actually had to measure amps using a multimeter. Click here to watch the next video. It is the best free thing you can do to tell YouTube to support the channel. Otherwise, if you want to do more, check out the links in the description. Thanks for watching.